Hello everyone. So today we are going to discuss about an experiment to determine the focal length of a convex mirror with the help of a convex lens of non-focal length by UV method using optical bench. So the apparatus required for this experiment are optical bench, a convex lens, uprights and lens holders, convex mirrors, and a scale. Now let's have a look on the theoretical background of this experiment. So let's see the position of a real image of an object O formed by convex lens L. Now if the convex mirror M is placed between L and C such that C is the center of curvature of it, then the rays refracted through L get reflected back by M along the same path and form a real inverted image at O. Under these conditions, Cm is the radius of curvature of the mirror and half of it gives the focal length of the mirror. Now to locate the position of C, the convex mirror is removed without disturbing the position of the object and the lens, and another needle is placed in the position of the image I of the object O formed by the lens L by using parallax method. So therefore if MC is equal to MI is equal to R, so then the focal length of this convex mirror will be half of this radius of curvature, that is MI divided by 2. Now let's talk about the parallax error. So one of the issues arises in the experiment of optics is the parallax error. So what is a parallax error? Suppose this one is the object, image 1 is the image of this object formed by the convex or concave lens. Now suppose this image 1 and the objects are in the same vertical plane and you are observing this image and this object through this direction. Now if the object is closer to your eyes compared to the image 1, and if you move your head perpendicular to the vertical plane where this image and this object lies, then you will find that the object which is near to your eyes, it will move faster compared to this image 1, and this object will move opposite to the direction of the movement of your head. Now if you bring this image 1 closer to the object, and for example image 2 is the new position of this image 1, then you will find that now the movement of this object becomes slower compared to the previous case. And again, if you move the object exactly in the same vertical line where both this image 3 and the object lies, then you will find that these two things, that is the object and the image 3, will move in the same direction according to the movement of your head. So this is the way how we can reduce the parallax error. On the other hand, if the image of this object is closer to your eyes, then you will find that now in this case the image 4 will move faster compared to the object, and this image 4, it will move opposite to the movement of your head. So you have to bring closer to again, or you have to bring this image 4 in the same vertical line where this object and the image lies. So this is the way by which you can reduce the parallax error. So this is the optical bench, and you can see that the scale lies on this optical bench where it can measure different distances, and this is the object needle, and this one is the convex lens, and this one is the convex mirror. And first we have to take out this convex lens to find out its focal length. So you can measure the focal length approximately by focusing a distant object on a plain white paper. So for example, in this case we are focusing this tube light on this paper by this convex lens. You can see we can focus this light very clearly. So you can measure the focal length of this convex lens by this scale. So here you can see I'm focusing this light by this convex lens, and let's see. So this one is approximately 21. So the focal length of this convex lens is approximately 21. Now you have to fix this convex lens on this lens holder, and we have to place this lens holder on the optical bench. Now before doing this experiment, what we have to do, we have to align this lens mirror and the object mirror in such a way that all these three are in a same plane or same line. You can see, so this needle is a little bit downward, so we have to adjust it, and we have to lift it a little bit so that the point of this needle exactly lies on the center of this mirror and the lens. Okay. Now see, we have placed this object needle at the 0 point in the scale, and you have to place this lens beyond its focal length. That means the distance of this lens and the object needle should be more than the focal length of this lens. So the distance between this object needle and the lens should be more than the focal length of this lens. So we are placing a beyond 21 centimeter from the object needle. Now we have to bring this mirror closer to this lens in such a way that the image formed by this object, by this mirror, will, if you look, then you will find, you look through this direction, then you will find that the image formed by this mirror so I'm adjusting to find out the image formed by this object, image formed by this mirror and the lens combination. And okay, let's so you have to adjust the mirror to find out the image, to see the image in that direction. Now it's almost done, you can see. So the height I need to adjust a little bit. So if you look through these directions, then you will find the inverted image of this object needle So you will find an inverted image of this object needle, and you have to stop this experiment here, and you have to take out the readings, different readings. That means you have to point out different readings. You have to point out the object lens and the mirror positions, and you have to note down. In the next step, you have to take out this mirror without affecting the object needle and the lens, right? So I'm taking out this mirror. So you should be very careful when you keep the mirror, otherwise it will break down. Now to find out the image formed by the lens, so we are placing a image needle on the other side of this lens, and we will look through this direction to find out the image formed by the object. Image formed by this lens. So always remember that you should not disturb the position of the lens. So you have to do this like that. Now this is done, so you will find an inverted image in this direction. If you look through this direction, so you will get a inverted image formed by this object. Alright, so this is the image locations of the image formed by the object needle, and you have to correspondingly note down this position. Now same thing you have to repeat again by changing the position of the object. So this time we are changing the position of the object, then again we will fix the mirror. And we have to take out this needle. And you have to do the same experiment, or you have to repeat the same procedure again for different locations of the object. Alright? So this time the object needle is a 10 centimeter. So we are again we have to again do the same thing. So we have to take out this needle, then we have to place the other needle to find out the position of the image formed by the convex lens. So this way you have to take 3, 4 or 5 readings. Okay. So this is the table to find out the focal length of the convex mirror. So before that, first you have to note down the approximate focal length of the lens. Then you have to note down the object needle, that means the position of the object needle, then lens, then mirror, and then image needle. And then from this data you have to find out the observed radius of curvature. Then simultaneously you can find out the focal length. So you have to repeat the experiment for 5 times, and after taking the data you have to take the mean of this focal length, and that would be the measured focal length of the convex mirror. So when you do the experiment, you should take some precautions. So principal axis of the lens should be horizontal and parallel to the central line of the optical bench. Then all the uprights should be vertical. The tip of the needle, center of the mirror, and the center of the lens should be at the same height as we have discussed before. Then while removing the parallax, the eye should be kept at a minimum distance of 30 cm from the needle. Tip to tip parallax should be removed. Index correction should be applied between the image needle eye and back surface of the convex mirror. The convex mirror should be placed close to the convex lens. And for one set of the observations, when the parallax has been removed for convex lens alone, the position of the lens and the needle O uprights should not be changed. So these are the some precautions you should maintain when you do the experiment.